In this video, we'll take a look at the molecular geometry for ClO2-. This is the chlorite ion. So when we look at this here, this is the correct Lewis structure. If you need some help with that, there's a link in the description of this video. We have our chlorite ion here. We can count up what's called the steric number. These are the number of electron domains around the central chlorine atom here. So we have the two oxygens, and then we have the two lone pairs. So we have a steric number of 4. So with a steric number of 4, we next want to look at the lone pairs. So we have the two lone pairs there. That means with those two lone pairs, we go over here and down, and that has a bent molecular geometry. Bond angle's about 109.5. Let's take a look at that though and see what it looks like. So I have the two oxygens. I have a single bonded oxygen and a double bonded oxygen. Those spread out as far away from each other as they can. A lone pair, which pushes everything down. And then we have another lone pair. So we have two lone pairs, and that pushes these hydrogen atoms down. These lone pairs occupy a good bit of space. Bond angle should be about 109.5. I would think it'd be a good bit less though, because we have two lone pairs, and you can see the lone pairs, they take up more space than the hydrogens, and as they push down, the hydrogens are moved closer together, and that gives us a smaller bond angle. Let's go back to the Lewis structure in the table. So for the ClO2- Lewis structure, we have a molecular geometry called bent, and we have bond angles of about 109.5, actually probably a little bit less than that. This is Dr. B with the molecular geometry for the chlorite ion, ClO2-. Thanks for watching.